The sun never moves here, and something is watching. Life around red stars. What if the most likely place to find intelligent life isn't a world like Earth at all? What if it's a planet you can't see with the naked eye, orbiting a star so faint it barely whispers across space? Not yellow, not brilliant, but red. Red dwarfs are the most common stars in the universe. Small, quiet, burning slow, and for decades we thought they were too unstable, too dim, too dangerous for life. But we were wrong. In this episode, we journey to the twilight world of Helios, a super-Earth orbiting one of these ancient stars, a place of black forests, blood-red skies, and something more, something thinking. If you thought life around orange stars was strange, you haven't seen anything yet. Red dwarfs, or M-type stars, are the quiet workhorses of the cosmos. Small, faint, and slow to burn, they make up nearly 80% of all stars in our galaxy. But despite their overwhelming numbers, they're easy to overlook. That's because they shine so dimly, you'd never see one with the naked eye. Even the closest star to Earth, apart from the Sun, is a red dwarf, Proxima Centauri, just 4.24 light-years away. It's right next door in cosmic terms, yet invisible to the unaided eye. Its light is too faint, too soft, too slow burning to pierce the sky like the stars we know. Now contrast that with the North Star, Polaris. It's 433 light-years away, more than 100 times farther than Proxima, and yet, on a clear night, it glows steadily above the northern horizon. Why? Because Polaris is not a red dwarf. It's a supergiant, a star that burns bright and dies young. It roars with light while Proxima whispers. It's a humbling truth. The stars we see in the night sky are not the ones most likely to host life. They're just the loudest. The real story of the cosmos, the slow, ancient one, is written by stars we cannot see. Red dwarfs burn at just 0.01 to 0.1 times the brightness of our sun. Some emit less than 1,000th of its light. They are often only 8% to 60% the sun's mass, with surface temperatures ranging from about 2,300 to 3,800 degrees Kelvin, a far cry from the sun's 5,778 Kelvin. And while our sun, a G-type star, white in truth, though yellow through our sky, will blaze for 10 billion years, red dwarfs stretch their lives across trillions. They are not stars of stories and myth. They are stars of silence, patience, and eternity. Because the habitable zone, that narrow band where liquid water might exist, is so close to these stars, any planet orbiting within it would likely become tidally locked. That means one side of the world always faces the star, trapped in eternal daylight. The other remains forever turned away, locked in endless night. On such a planet, there are no sunsets, no dawns, no cycles of day and night, just a hemisphere scorched by unrelenting light, and another frozen beneath an eternal void. The day side would bake under the star's dim but constant glow, slowly roasting its oceans, evaporating into dense, swirling cloud layers. Meanwhile, the night side would be a kingdom of ice, locked in darkness. But for any planet orbiting a red dwarf, the greatest threat may not come from darkness or cold, but from above. Young red dwarfs are chaotic. In their early lives, they emit powerful stellar flares and intense solar wind, streams of charged particles that surge outward like invisible tempests. These violent outbursts can batter a nearby planet's atmosphere again and again. Over time, that relentless bombardment can do something devastating, strip the atmosphere away. This happens because solar wind carries energy and particles that slam into a planet's magnetic field and upper atmosphere. If the planet doesn't have a strong enough magnetosphere, the protective bubble generated by a molten, spinning core, those charged particles begin to erode the atmosphere, molecule by molecule, sweeping it into space. It's a fate that may have already happened in our own solar system. Mars once had rivers, lakes, and possibly oceans, but its small size meant its core cooled early, and when that happened, it lost the magnetic field that shielded it. Without that protection, the solar wind gradually tore away its atmosphere. Today, Mars's air pressure is less than 1% of Earth's. It is a world of dry riverbeds and lost potential. Earth, by contrast, is still alive inside. Our spinning, molten core powers a strong magnetic field, and that field deflects most of the solar wind that would otherwise strip away our air. Without it, Earth might be just as barren. Now imagine a world orbiting a red dwarf, much closer to its star than Earth is to the Sun. Imagine it being pummeled daily by flares 1,000 times stronger than those we see here. Unless it has a thick, resilient atmosphere and a powerful magnetic shield, it may not keep that air for long. And without an atmosphere, there's no surface pressure, no liquid water, no protection from radiation, and no life, at least not as we know it. That's because liquids need pressure to exist. Without enough atmospheric pressure, water can't stay in its liquid form. It either freezes or boils away into gas, even at low temperatures. That's why there is no liquid water in space. Not naturally, not in open vacuum. You can have ice, you can have vapor, but never a stable drop of water. Take away that pressure, and even a world rich in water would lose it. Oceans would sublimate into the sky. Rivers would vanish in clouds of vapor. The planet becomes dry, cold, and silent. Now imagine the same process, but more violent, faster, driven by a red dwarf's furious youth. For many of the planets orbiting these common stars, that may be the end of the story, but not for all of them. Some might endure, some might fight back, and some might still, even now, harbour life, because red dwarfs are so dim their warmth doesn't reach far. To stay in the habitable zone, the delicate region where temperatures allow liquid water to exist, a planet must orbit very close to the star, much closer than Earth is to the Sun. We're talking just a few million kilometers, closer than Mercury's orbit. So close, in fact, that an entire year might pass in just a handful of Earth days. The planet would be locked in a tight gravitational embrace. And that closeness creates problems. We've already seen how such proximity can trap a planet in tidal lock, dooming one side to endless day and the other to eternal night. But the dangers don't end there. The intense stellar activity of young red dwarfs, the flares and solar storms would strike the planet again and again, delivering powerful bursts of radiation. If the world didn't have a strong magnetic field, those charged particles would slam into the upper atmosphere, heating and thinning it until eventually it was stripped away completely. Without that atmosphere, any chance of liquid water would vanish. There would be no pressure to keep it stable. Only vapor or ice or nothing at all. To survive such harsh conditions, a world would need to be extraordinarily lucky. It would need just the right mass to hold onto its heat, to keep its core molten and spinning, generating a magnetic field to deflect the worst of the solar wind. It would need an atmosphere thick enough to trap warmth and circulate it from dayside to nightside, smoothing out the extremes. It would need to cling to equilibrium, barely, but just enough. And that sounds unlikely, but there are so many red dwarfs, hundreds of billions in our galaxy alone, that even if only a tiny percentage of their planets hit the cosmic jackpot, that would still leave us with millions of possible havens. Silent, invisible, orbiting stars we cannot see with our eyes, worlds that do not shine but endure. And maybe, somewhere out there, life is not just surviving under a red sun, but thriving. And while the odds of habitability around any one red dwarf might seem slim, the universe doesn't run on odds, it runs on scale. There aren't just hundreds of billions of red dwarfs, there are trillions upon trillions, because we're not just talking about our galaxy. The Milky Way alone contains over 200 billion stars, and by most estimates, at least 70% of them are red dwarfs. That's more than 140 billion slow-burning embers, each with its own retinue of planets. But our galaxy is just one among many. In the observable universe, the part we can see, limited only by the speed of light and the age of space itself, there are estimated to be at least 2 trillion galaxies, and while some are small and sparse, others are sprawling giants. On average, each galaxy holds 100 to 200 billion stars, just like our own. Do the maths, and you get a number so large it's almost meaningless. Around a septillion stars, that's a 1 followed by 24 zeros, and most of them, again roughly 70%, are thought to be red dwarfs. These tiny, quiet stars don't scream for attention like their brighter cousins. They don't make up the constellations or burn across myths and calendars, but in sheer number, they dominate the cosmos. And that changes everything. It suggests that the most likely homes for life in the universe are worlds we can't even see. Not yet. And now let's narrow our gaze. We've spoken of trillions of stars, of billions of galaxies, but among them, scattered through the endless dark, there are outliers, the lucky ones, and we're going to talk about one such star. It's nestled in a spiral arm of a distant galaxy, a red dwarf, yes, but not one of the feeblest. This one is larger than most, on the upper edge of its class, brighter, warmer, more stable, a silent and dim glow in a quiet corner of the cosmos. And orbiting close to it, not too close, but just right, is a planet with a thick, resilient atmosphere, one that holds in warmth, protects from radiation, and smooths out the chaos of a star still whispering with the remnants of its youth. Its skies are dense but breathable, its temperatures balance between the eternal day and the unbroken night. This world is called Helios. It is not real, not yet, but it could be. It's a thought experiment shaped by physics, possibility, and a touch of wonder. A planet that might orbit one of the trillion red dwarfs spread across the observable universe. We can imagine its red sun fixed high in the sky, unmoving but steady, its winds circling from hot side to cold, its clouds streaked with gold and rust, a place of calm and chaos, of extremes and equilibrium. Helios is a promise of what might be. And now, let's explore it. Helios is a super-Earth, a rocky world roughly 3 times the mass of our own. Its gravity is stronger, its atmosphere denser, and its weather system slower but more immense. With a diameter of around 20,000 kilometers, it dominates the space around its star with quiet power. But from orbit, it doesn't look like the Earth. There is no blue marble glinting in sunlight, no swirl of white clouds over turquoise seas. From space, Helios looks almost black. It appears cloaked in shadow, as if carved from obsidian. Only the faintest sheen of deep ocean reflects its red star's dim light, like blood glinting off coal. Its surface is muted, its details veiled, as though it's hiding something beneath. And it is, because that darkness is not the absence of life, it's the signature of life, a surface that doesn't reflect light because it's absorbing it. We'll get to that later. For now, we descend into a world where the sun never moves, where wind roars from heat to cold, and where the very air is heavy with possibility. We descend now through the thick, high-pressure atmosphere of Helios. The clouds part slowly, dragging long shadows across a vast and alien landscape. Below us, the planet's star looms in the sky like a god, enormous, red and unblinking. It does not rise, it does not set. It simply hangs there, forever suspended, locked in place by gravity and time. Its crimson light spills across the world like liquid fire. We touch down near a coastline, and the scene before us is both haunting and breathtaking. A black sand beach stretches along the edge of a vast, slow-moving ocean. The sand is fine as ash and glints only faintly where the light catches the grains, not because it is lifeless, but because the world is designed to drink in every photon. The ocean reflects the red sun like a pool of molten wine. No blue here, only deep maroon and glistening minerals forged in heat of ancient solar flares, disturbed occasionally by gentle waves. It is thick, heavy, as though the very air is pressing down on everything, muffling sound and softening the movement of wind and water. Above, the sky glows a deep, dusty red, fading to purple near the edges of the horizon. High-altitude clouds, stretched thin by the planet's slow atmospheric circulation, catch the starlight and shimmer like rusted gold. It should feel eerie, perhaps even wrong, but instead it's sublime, like walking through a living painting, a world painted in shades of iron and flame. And through it all, the star watches, motionless, immense, as though time has paused. And perhaps it has, in a way, because this world doesn't live by days and nights. It lives by gradients, by the way heat shifts and flows, by how life adapts not to cycles, but to stillness. There are no seasons. The stars don't move. There is seldom anything to mark the passage of time. Yet it is beautiful and utterly, utterly alien. As we move inland, the surface of Helios reveals itself, a world shaped not by weather but by pressure, heat and time. Vast glass plains stretch across the dayside, where ancient flares once melted the sand into warped, mirror-like sheets. Here we see vast pressure mountains. Helios doesn't just shape mountains, it squeezes them into existence. Forged by relentless internal pressure, these jagged spires are the planet's bones, forced skyward over billions of years. Scattered among them stand silicate forests, brittle spindles of crystal grown from volcanic vapor, silent and sharp as bone. And then the ground splits. Lava wounds curl across the crust, slow, glowing fissures that bleed magma in spirals, lighting the dark stone with a dull, living pulse. It is a harsh, alien beauty, because between the star-scorched side and the frozen wastes, there's a place where the light softens and the air shifts, a place of eternal twilight. This is the Terminator Zone, the narrow ring where day and night meet and where, just maybe, life begins. Let's go. Stand in the Terminator Zone of Helios and look up. The star never moves. It hangs there, low on the horizon, a vast, swollen orb of red, frozen in place, half in view, half below, as if caught in the middle of an eternal sunrise that never comes. It casts the world in a perpetual dusk. Shadows stretch forever, soft and blurred, while the sky shifts between ember red and violet black. There is no true day here, no night, just a slow, endless burn of twilight. The light is dim, but not lifeless. It bends through the thick atmosphere, painting the land in surreal colors. Orange mist over dark soil, copper glints on rippling pools, and distant ridgelines bathed in blood and fire. Here, the sun is not a source of time, it is a landmark, a fixed compass in a world without clocks. And it is this strange equilibrium, this delicate balance of light and dark, that may offer life its best chance. Beneath the crimson sky of the Terminator Zone, the land is not barren, it breathes. Low to the ground and clinging to every surface, vegetation spreads like living shadow, black as coal, matte and lightless. At first glance, you might think it's ash or rock, but look closer and you'll see it move with the wind, stretch toward the star, ripple like a field of soft fur. This is not green, because green would be wasteful here. On Earth, plants use chlorophyll to absorb red and blue light, but reflect green. The reason our forests are lush with emerald hues. But Helios offers no bright blue sky, no full spectrum, only the deep red glow of a distant, dim sun. And so, evolution took a different path. Over millions of years, the plants of Helios developed dark pigments, far more efficient than chlorophyll in this spectral wasteland. They absorb nearly all wavelengths of the meager light available, turning every precious photon into energy. No reflection, no brightness, just function. The result is a biosphere that drinks the light. From space, the planet looks almost black. Now we know why. The darkness isn't lifelessness. It's the signature of life adapted to survive in a world where light is scarce and precious. This is evolution under a red sun, and it is nothing like Earth. We step now into one of Helios's great forests. Not trees, exactly. Not as we know them, but something deeper, stranger. The ground is covered in thick, velvety mats of shade weavers, spreading in dark, endless carpets between jagged stones. They shift almost imperceptibly in the breeze, not rustling, but shivering, a soft ripple that travels across the forest floor like a whisper. They don't grow tall, there's no need. With the red dwarf fixed forever in the sky, they simply stretch outward, drinking the light as it comes. Rising from this black meadow are the pulse ferns, great spiral-fronded stalks, each several meters tall. Their surfaces are dull and leathery, covered in microscopic ridges that scatter heat and resist flare damage. Every few days, they quiver, unfolding their long black fronds to expose deep crimson interiors, absorbing as much light as possible before coiling shut once more like fists. Above us, draped over obsidian cliffs and basalt outcrops, the heliovines hang like organic cables, looping down to the ground in broad, gentle arcs. Their tips sway ever so slightly, aligning with the unmoving star, like devout worshippers, frozen in mid-prayer. Their stalks pulse slowly with dark sap, like veins carrying the lifeblood of the forest. The air is thick and humid, scented faintly of minerals and decay. It's quiet, but not silent. Somewhere, the slow drip of condensation echoes off stone, the occasional groan of a pulse fern adjusting its posture, and beneath it all, the soft, living hiss of shade weavers releasing tiny gas bubbles as they convert red light into energy. The colors here are surreal. A world painted in shadows and ember light, black, red, violet, with flashes of glowing blue or purple, where a black bloomer has opened in the distance, shedding a brief pulse of bioluminescence into the thick air. Nothing here grows fast, nothing here wastes energy. This is not a forest of growth, it is a forest of patience. And yet, in this slow-burning world, life thrives. In the dim hush of the forest, something stirs. Pushing through the thickets of shade weavers comes a creature, low to the ground, broad and dense, an amber grazer. Its body is squat and muscular, built for high gravity and slow, deliberate movement. Its skin is a mottled blend of black and rust red, not for show, but for camouflage, to vanish into the gloom of twilight. Two wide eyes, glossy and deep orange, scan the forest with a kind of wary calm. They're tuned not for sharpness, but for contrast, able to detect even the faintest difference in heat or light. Around its mouth, soft, bristle-like tendrils brush the ground as it feeds, stripping shade weavers in slow, rhythmic motions. Its jaw grinding plant matter between plates of organic ceramic. It makes no sound, but every so often, a low hum escapes its chest, not a call, but a kind of resonant pulse, felt more than heard, perhaps a way to map its surroundings, perhaps a warning, or perhaps it just echoes the vibration of the forest around it. But the grazer is not alone. High above, curled around the trunk of a pulse fern, something waits. It is nearly invisible, a glow stalker, long and serpentine, wrapped in the coiled shape of the plant. Its body is cloaked in shifting pigments that mimic the bark and shadows perfectly. You wouldn't even know it was there, if not for the faintest light. At the tip of its tail dangles a lure, a soft, bioluminescent bulb pulsing with blue and violet hues not found anywhere else in the forest. In this world of reds and blacks, the unnatural light is magnetic. The grazer pauses. Its eyes catch the flicker, and it turns, not quickly, just curiously, and in that moment, the glow stalker uncoils silently from the fern, descending like a wisp of smoke. No rush, no roar, just precision. It strikes with a flash of movement too fast for this slow world, and the forest returns to silence. Predator and prey, both perfectly adapted to a world that never moves. Here, the food chain is not ruled by speed, it's ruled by patience, deception, and light. Beneath the surface of Helios's dark oceans, the world grows quieter still. The water is thick with dissolved minerals and heavy elements, tinted a deep maroon by the red light filtering down from above. Sunlight barely penetrates more than a few meters, and even there it arrives as a faint shimmering haze, not gold but crimson. But the darkness does not mean emptiness. The oceans of Helios are alive, glowing softly, pulsing gently, filled with movement that's more felt than seen. A veil ray passes just beneath the surface, a broad, undulating creature with a flattened body and long trailing fins that ripple like silk in slow motion. Its skin is almost completely black, save for a cluster of bioluminescent nodes along its back that pulse in waves, creating ripples of pale violet across the water. It doesn't see in light, it senses temperature, vibration, and the chemical trails of life around it. Deeper still, long strands of driftweed sway in the current, not true plants, but flexible colonies of photosynthetic organisms clinging together in spiraling, tubular structures. Small filter feeders, like glowmouths, nestle among them. Fish-like beings with translucent skin and a ring of lights around their jaws guiding them through the gloom. And in the deepest trenches, where geothermal vents crack the ocean floor and release slow clouds of heat and minerals, stranger things dwell. Pulse worms, 2-meter-long, eel-like organisms, orbit the vents in lazy spirals, absorbing warmth and bacteria in slow, open-mouthed feeding. They glow with a faint blue rhythm in time with the heartbeat of the vent. Every now and then, a shape too large to name drifts past. No eyes, no mouth, just movement and silence. The ocean of Helios is not loud, it does not sparkle, but it is ancient and patient and full of secrets. It doesn't happen often, maybe once every few years or even decades, but when it does, the oceans of Helios come alive in a way that defies belief. It begins deep beneath the waves, with a shift in pressure, a subtle warming of the currents, or perhaps something older and more instinctive. Whatever the trigger, it sends a signal through the layers of water, like a whisper passed between worlds. And then the bloom begins. From the ocean floor to the surface, countless microscopic organisms awaken. Bioluminescent plankton, dormant for years, erupt into radiant light. They surge upward in spirals, carried by rising currents, turning the ocean into a slow-moving storm of colour. Blues, purples, and eerie shades of green ripple outward in great living waves. Creatures rise with them, glowmouths, veil rays, even massive drift whales, with glowing ribs visible beneath their skin. Schools of smaller life forms flicker in synchrony, flashing in complex patterns like living circuitry. On the surface, the water boils with light, the waves glow red at their base, then turn electric violet at the crest, as though the planet itself were trying to outshine its dim star. And above it all, the skies respond. Floaters, those massive jellyfish-like organisms in the upper atmosphere, drift toward the coastline in slow convoys, releasing their own light in response. Not communication, exactly, more like a resonance. A planetary chord struck across sea and sky. It lasts for hours, sometimes longer, because this bloom, this eruption of living light, isn't just a local spectacle, it's visible from space. From orbit, Helios briefly transforms. The black hemisphere of ocean, usually indistinguishable from shadow, begins to glow. Great swirling patterns of colour spiral across the terminator zone, not static, not random, but rhythmic. As if the planet itself were signalling. A world not just alive, but active, and if anyone, anywhere in the universe, were watching in just the right moment, they'd know. And then, just as slowly as it began, the lights recede, the sea darkens, the creatures vanish into the depths once more. Silence returns, but Helios holds more than plant life and grazers, more than bloomstorms and drifting shadows in the sea. Because in the coastal shallows of the Terminator Zone, there is something else. A species, tool users, thinkers, early but rising. They are called, for now, the Selenids, amphibious, low-slung beings with elongated limbs and dense, fluid motion. Their posture is neither upright nor quadrupedal, but something in between. A loose, flowing crawl that becomes an awkward but determined walk when they reach the land. Their skin is dark and slick, adapted to both water and air, and their broad eyes glimmer with red reflections, always turned skyward, because they hunt what flies. In the open clearings beneath the pulse ferns, the Selenids build strange structures, not permanent shelters, but lattices of woven shade weaver fibers strung between stones or draped across low ridges. At first, they seem like art or perhaps camouflage, but when examined up close, they are snares. Whisper wings, the slow, gliding aerial feeders of Helios, are drawn to the glowing black bloomers that grow near water, and when they descend, gently, silently, they become entangled in the Selenids' traps. A struggle, a flicker of bioluminescence, and the forest returns to stillness. The Selenids approach carefully, with stone tools in hand, sharpened fragments of volcanic glass used to pierce wing membranes and harvest soft tissue. They work together, 2 or 3 at a time, using coordinated gestures and low-frequency clicks to communicate. Not language, not yet, but intention, agreement. But what is clear is intelligence. They build, they plan, they adapt. And on the stone outcrops above their traps, they leave marks, spiral glyphs etched with glass, sometimes simple, sometimes elaborate. Perhaps they're territorial, perhaps they're simple hunt stories, early memory carved into a planet that forgets nothing, and in a world of silence and slowness, the Selenids are beginning to shape their world. One woven thread, one carved stone, one whisper wing at a time. Near the coasts, where the lava wounds spiral through the crust, they gather in small groups around geothermal pools, shallow, open pockets where heat rises from beneath the surface in waves of distortion and sulfuric mist. To us, they might seem dangerous, but to the Selenids, they're an opportunity. They bring with them flat stones, selected carefully for shape and density. They place them along the edges of the lava pools, waiting patiently as the rocks heat over the course of hours, absorbing the steady warmth until they're almost too hot to touch. Then, with slow precision, they take the flesh of whisper wings and other caught prey, soft cuts harvested with obsidian tools, and place them atop the stones. There are no flames, no smoke, just cooking, born from silence and patience. The fat sizzles gently on the warm rock. The air fills with scent, and the Selenids wait, not hungrily, not chaotically, but in stillness, in order. Some watch, others humming, low, resonant tones, perhaps a form of social bonding, perhaps just rhythm. Then the food is shared, evenly, methodically, pieces passed from hand to hand, or placed gently before smaller members of the group. They are not advanced, but they are more than animals. And here's the part that should stop us in our tracks. The red dwarf above them, the star that casts its crimson glow across the beaches, the forests, the bloom-lit seas, will not die anytime soon. It is stable, quiet, patient, and it will remain so for trillions of years. Not billions, trillions. That's hundreds of times longer than the current age of the universe, which, for all its galaxies and grandeur, is just 13.8 billion years old. The Selenids and their world are infants by comparison, but the fire above them will burn long after the Milky Way itself has faded, and they are learning. They craft tools, they trap prey, they cook with volcanic heat, they carve symbols into stone, they cooperate, they pass on knowledge, they remember, and they have time, more time than any species on Earth was ever given. Given patience and peace, they could build cities. Given millennia, they could reach orbit. Given eras, they could spread through the stars, not in a flash, not in conquest, but in quiet inevitability. The Selenids do not yet look to the sky and dream of rockets, but one day they might, because on Helios, under a red sun that never dies, the future isn't racing toward them, it's waiting. The Selenids are just one thread in the tapestry of Helios. There is so much more to explore, their tools, their rituals, their strange marks left across the stone, perhaps even the first flickers of language, but that is a story for another time. If you want to follow their journey from the oceans to the stars, subscribe to Stellar Stories. This is just the beginning, and if you haven't seen it yet, click now to watch Life Around Orange Stars, where it all began. Expect much more like this to come. See you next time.